All right, this is for Advanced Algebra 1, Topic 6, Section 6. So, definitions. This is a radical symbol. Then the number that appears here, index. The thing that appears underneath here is called the radicand. And so, you can have cube root of 7 is 3, square root of 16 is 4, the sixth root of 64 is 2. So that's why some people, instead of saying square root of 16, say radical 16. Is a radical symbol. Square root only pertains to when this index is 2. And for the square root, if there's nothing written here, it's understood to be the square root. We don't generally write, the square root of 25 is 5. Don't generally write the 2 square root because that's the one we do most. Okay. Then we have some rules for multiplying exponents and when do we add exponents and all kinds of stuff. So if I have a to the m, the n power, this is where I call it a power of a power or a power raised to a power. We multiply those exponents. So x to the second to the third power is x to the sixth. 2x squared to the third power is 2 to the third x to the sixth, or 8x. And that's what this second rule is saying, that if I have 3a squared to the third all to the third power, I multiply the exponents. That's 3 to the third, a to the sixth, b to the ninth. Then you can multiply 3 to the third is 27. Okay. Then we have a situation where I call it the same base. So when we have a to the m times a to the n, we add the exponents. A to the m plus n. So x to the third times x to the fifth is x to the eighth. We add those exponents together when we have the same base. This is not a power being raised to a power. Same base, add the exponents. One I like to throw in is 5 to the fourth times 5 to the third, and that is 5 to the seventh. Add the exponents, the base stays the same. Okay. If you're dividing and they have the same base, you subtract the exponents. So if I have x to the fifth over x cubed, that becomes x to the 5 minus 3, which is x squared. If it's the other way around, where I have x cubed over x to the fifth, instead of writing that as x to the 3 minus 5, which is x to the negative 2, we say that this is 1 over x squared. We keep the exponents positive unless we're asked to do something. Okay. So what we like to do is we like to write exponents with rational numbers rather than using the square root sign. Okay. So basically, the way that works is if I have the cube root of 3 to the fifth power, that is 3 to the 5 thirds, or the square root of 5 to the fourth power. No, that's not a good example. 5 to the seventh power, then that is 5 the 7 halves. The reason I went back on square root of 5 to the 4th, because that would be 5 4 halves, and technically we should reuse that fraction. 4 divided by 2, or 4 over 2 reduces. But essentially, and if I have 3 to the 1/3 times 3 to the 2/3, that same base, I can add those exponents. 1/3 plus 2/3 is 3/3, which is 1. That would, and that's one of the things that fractional exponents allow us to do. We can't do when we have the square root of something or the cube root of something. If they have the same base, I could actually combine them. So to solve these equations, we match the base, which is already done. So on this side, I have the same base. I can add those exponents. So going off to the side here, x over 2 plus x over 3, common denominator would be 6. So that would be 3x over 6 plus 2x over 6, which is 5x over 6. So this is 3 to the 5x over 6 equals 3 to the 9th. Okay? What I can do, now that I have the same base, and I only have one base on each side, I can set those exponents equal to each other. So that means 5x over 6 equals 9. And I can solve that for x now. So 5x equals 54. X is 54 over 5. And we just leave our answer as a fraction, obviously. When we start with fractions, we end with fractions. Another example, I have 2 to the x over 4 times 2 to the x over 6 equals 2 to the 3rd. So x over 4 plus x over 6, my common denominator would be 12. So this would be 3x over 12 plus 2x over 12, which is 5x over 12. And so here I have 2 to the 5x over 12 equals 2 to the 3rd. And now that I have the same base, one on this side, one on this side, I can set those exponents equal. 5x over 12 equals 3. So 5x equals 36. X is 36 over 5. And again, we just leave our answer like that. Here we go. So these bases don't match quite yet, right? 1 over 125. 125 is 5 times 25, and that's 5 times 5. Okay, so 125 is 5 to the 3rd. And because I have it written like this, I'm actually going to write it as 5 to the negative 3rd, and that's being raised to the negative x over 2 power. 25 is 5 to the negative 2, right? 1 over 25 would be 5 to the negative 2. And I'm going to raise that to the minus x over 2 minus 2 power. Now to simplify those, because I can't set the exponents equal to each other yet, even though I have the same base, because I don't have it written to one exponent. So what I need to do now is, this is a power raised to a power, so I need to multiply those exponents. And I get, and this is why I wrote it as 5 to the negative 3, because when I multiply these, I'm going to get positive 3x over 2. And over here, I'm going to have negative 2 times the quantity minus x over 2 minus 4. And so when I distribute this, I'm going to get x and then plus 8. And now I would multiply both sides, everything by 2 to get rid of that fraction. So 3x equals 2x plus 16, and x is, sorry, I went a little fast there. Subtract 2x from both sides, and x is 16. Okay? And then another example where we need to match the bases, 256 is 16 times 16, and that is 4 times 4 and 4 times 4. And I could take the base all the way down to 2, but I can also match the bases at 4. 256 is 4 to the 4th power, and that's being raised to the x plus 2 equals 4 to the 3x plus 9. So now on this side I would multiply those exponents. So 4 to the 4x plus 8 equals 4 to the 3x plus 9. And set the exponents equal to each other now. 4x plus 8 equals 3x plus 9. Subtract 3x from both sides, and I get that x plus 8 equals 9. Subtract 8 from both sides, x equals 1. Okay. So we have two terrariums, terrarium A and terrarium B, and they are cubes. And the side length of terrarium A is twice the side length of terrarium B. That's a lot of words. It's a hard word to say. And we want to find the value of x. Well, I want to make this one x by x by x. And so if I were to write the volume of this smaller one, obviously the smaller one is terrarium B, the volume in terms of x would be x to the 3rd power. Because to find volume, we take x times x times x. Okay. Over here, these sides are twice as long. So this would be 2x, 2x, and 2x. So and this is terrarium A, and its volume in terms of x would be 2 times 2 times 2 is 8. And then x to the 3rd power. Okay. So then they give us the volume of terrarium A. It's 2 to the x. And we just figured out that that's 8x to the 3rd. In terrarium B, the volume is 2. And so that's 2 equals x to the 3rd. So what I want to do is I want to substitute this 2 into this equation for x to the 3rd. Okay, and so then that gives me 2 to the x equals 8 times 2, or 2 to the x equals 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So 16 is 2 to the 4th. So what does x equal? X equals 4. Okay, and that's it. Online homework. And if you need help, as always, come in.